All right, guys, moving on to lesson 0.2 of reasoning explaining. A lot of this, again, is going to be review. Some of it might seem a little new, but you'll recognize it. We're going to represent situations symbolically. We're going to understand the meaning of quantities, not just how to solve it, but then what do they mean at the end. We're going to be able to justify that. And then we're going to be able to critique the reasoning of other people, why they might or might not be correct. Okay? So, first, quick question. We have B is the number of tennis balls, C is the number of cans, so we're using a model here, like we talked about in the last lesson, and we're using these symbols to represent quantities. B is the number of tennis balls, C is the number of cans, 3 balls in each can. What equation links B and C? So Ada says that C, or cans, equals 3 times the number of balls. Vern says that the balls is 3 times the number of cans. Which one is correct? So what would we multiply? Would we multiply the cans by 3, or would we multiply the balls by 3? Well, hopefully you're coming to this conclusion. There are 3 balls in each can, so we're going to take the number of cans and multiply that by 3 to get the total number. So just a quick launch or quick warm up there. All right, language is designed for describing qualities rather than quantities. So in math, we're going to use symbols for describing quantities. Right? We've done this many times before in algebra. Very helpful problem-solving technique is to use symbols to represent numbers that quantify things like time, weight, distance. Those are some common ones. So let's take a look at a problem. So first example. When Adam and his sister Megan arrive at a party, they see that there is 1 adult chaperone every 4 kids. So notice that's a ratio. Behind them come 30 more boys. And Megan notices now that the ratio is 2 boys to 1 girl after those 30 boys enter. However, behind the 30 boys come 30 more girls, and Adam notices that there are now 4 girls for every 3 boys. What is the final ratio of adult chaperones to kids? So there's some ratios that we have to set up first. There's some equations that we have to set up first using these ratios and everything that I've underlined. So let's start at the beginning. 1 adult chaperone for every 4 kids. All right, so how are we going to set up an equation that represents that? When we think about how to set up this equation, let's think about the ratio. The ratio is 1 to 4, and that's adult to kids, right? So it looks like, let's try to switch here. My first equation is going to be a ratio that represents adults to kids. So adults to kids, well, there are boys and girls. So adults to boys plus girls, and that ratio is 1 to 4. So there's our first equation. Let's look at what comes next. All right, so we finished that. What about the next part, right? Behind them come 30 more boys, and the new ratio is 2 boys to 1 girl. So now we have a ratio that's boys to girls, and there are 30 more boys that come in. So I'm going to say, and I already have this written down, I'm going to say my next equation is going to be boys plus 30, 30 more boys enter, so this one right here. So 30 more boys enter compared to girls, and that new ratio is 2 to 1. So does that make sense? We look at this, 30 more boys enter, so boys plus 30, compared to the girls, and that ratio is 2 boys to 1 girl. All right, now third one. However, behind the 30 boys come 30 more girls. And Adam notices now that there are 4 girls for every 3 boys. So now I have a ratio that's girls to boys, right? So and that ratio is 4 to 3. Let's go here and we're going to say our ratio now is 4 to 3. And we said there were 30 more girls. So I have boys plus 30. So the girls plus 3 is 43. Right, up to 3. All right, so let's take a look at the questions. Always know the question, right? What is the final ratio? Chaperone to kids. So we want a ratio of adult. Well, ways to solve this problem. So you do not have to do it the way that I'm going to do it. All right? But let's just get this started. Let's simplify a couple of things maybe first. Let's take a look at this one. Let's rearrange this a little bit. If I just want to know what A is, what if I multiply both sides by B plus G? I'm going to have A equals 1/4, excuse me, 1/4 B plus G, or I could just write that out. B plus G over 4, right? All right, well, what about if we go to this next one? Let's just try to get some things out of the denominator. So if I want to get G out of the denominator, I could multiply both sides by G, right? So if I multiply both sides by G, I'm going to end up with B plus 30 equals, multiply this side by G, it's just going to be 2G, right? Okay, so there's kind of a simplified version of my next equation. Okay, well, what about the third one? Well, if I want to, again, get rid of denominators like we've been doing, I'm going to multiply both sides by G plus 30. So that'll eliminate this denominator, right? G plus 30, that's what I said, right? So multiply both sides by G plus 30, and I'm going to end up with B plus 30 equals 4/3, or you could say just 4 times G plus 30 over 3, but I'm going to say 4/3 G plus 30. Okay. So I'm going to use these equations in blue to try to solve this problem we have here and find adults to kids chaperones. All right, so excuse the mess. I forgot my screen shade here, so we're going to do it this way. So I'm going to take that first equation, that G plus 30 equals 4/3 times 2G. And I'm going to, using that equation, sorry, not the first one, the second one, so using that equation too, I'm going to substitute 2G for B plus 30. I'm going to back that up a little bit. So let's look at our last slide. Oops, where'd it go? Here we go. So I'm going to take my second equation here. B plus 30 equals 2G, right? Okay, well, what if I take that B plus 30, where else do you see B plus 30? I see it right here, right? So what if I take that 2G and I substitute my B plus 30? So now let's go back here, right? So I've taken that that 2G and substituted it right here into equation 3. So now I have G plus 30 equals 4/3. Instead of B plus 30, now 2G, because those things are equal. Right? So let's go to the second step. So in my second step, I'm going to actually multiply both sides by 3 to get rid of that denominator. It'll just make it a little bit easier to work with. Right? So I multiply both sides by 3, again, to eliminate my denominator. I'm going to end up with 3G plus 90 equals 8G. So these are what those 2 equals. And when I multiply this by 3, I'm just getting rid of that denominator. So I have 3G plus 90 equals 8G. What does this do for me? Well, now I have G, right? I'm left with one variable. Now I have 90 equals 5G. And recall how to solve equations. I'm going to divide both sides by 5. And I end up with G equals 18. Look, it's a little easier from here. Now that I have the number of girls, I can use my B plus 30 equals 2G. Okay, so I've got B plus 30 equals 2G. I can substitute 18 for G. And I can come up now with my number of boys. So if I do this, I'm going to get the number of boys, right? So the number of boys, 36 minus 30 is 6. So I have boys is 6, girls is 18, but my question is adults to kids, right? So we're going to go a little bit more quickly through this last step. Now that I found my values for B and G, you can use that first equation to find your number of adults. So adults, that first equation, adults is 1/4 boys plus girls, right? So 1/4 of the boys plus the girls, or 1/4 of 24 is 6. So the number of adults is 6. So I had boys is going to be 6. Girls is 18. And I have adults is 6. Now don't make the same mistake I did and just say, well, the ratio of boys to girls or adults to kids is 6 to 24. I have to look back at that first equation because remember, 30 more girls and 30 more boys entered, right? So if I go back to that first equation right here, or sorry, not if I go back to the first equation. If I think about the 30 boys who have entered, the 30 girls who have entered, I have adults, which is 6, and then I have 6 boys plus the other 30, 18 girls plus the other 30. It's going to give me 6 to 84. If I simplify that, I'm going to get 1 to 14. So the final ratio of adults to kids is 1 to 14. Okay, this is a 4-step solution. This is one thing I want you to have written down in your notes, please. So what were the 4 steps to this solution? Assign a variable. Right? So assign a variable. Second, write equations for the information. Variables, B equals boys, G equals girls, A equals adults, and then we wrote equations for those. Okay, third, we solve the equations to find values for the variables. So whatever method you're going to use, and the way I did it might not be the way you do it, that's okay, there are multiple ways to solve those equations for the variables. Don't forget your solution. You have to know what that solution means. In other words, when you get your 1 to 14, you need to know that is the ratio, final ratio of adults to kids. So interpret that solution. Now, how many times people come up with a solution and I ask them what it means and they say, I don't know. If you don't know what the solution means, how do you know that you have the right solution, right? So you got to be able to interpret that. That's a really important step. Right, we're going to use those 4 steps, and we're going to go through this one just a little bit more quickly. All right, so we have 3 friends went to the gym to work out. None of them would tell how much he or she could leg press, but each one hinted at their friend's amount. So we have Chen, Juanita, and Lou. So if we assign variables, we're going to say, okay, Chen is C, Juanita is J, Lou is L. So we've assigned our variables. Okay, so Chen said that Juanita and Lou averaged 87 pounds. So now that we've assigned our variables, let's go ahead and create an equation for that. So Chen says that Juanita and Lou average 87 pounds. In other words, Juanita plus Lou, when I'm doing an average, I'm going to divide by how many there are, right? So I divide by 2. So there's one of my equations. All right, well, Juanita said that Chen leg pressed 6 pounds more than Lou. So Juanita says Chen's leg pressing is 6 pounds more than Lou. So Lou's pounds plus another 6. There's my second equation. And my third one, Lou says that 8 times Juanita's amount is 7 times Chen's amount. So 8 times Juanita's amount, 8J, is the same as 7 times Chen's amount. So there are my 3 equations. Hopefully those make sense to you. All right, so next we're going to take those and we're going to do what we can to solve those. So we've already written our 3 equations. You can see those up here, right? I know this gets a little confusing. This is one way to solve it. You do not have to do it this way. I'm going to use some elimination. If you remember solving systems of equations, I'm going to use some elimination here. I know that these red, green, and blue arrows get a little bit confusing. All right, so here's what I'm going to do. If I have J plus L, now what I've done here is I've gotten rid of this denominator, right? So now I have J plus L equals 174. So that's where I got this right here. And I'll multiply both sides of the equation by 2. And then I have C minus L equals 6. All right, so remember our equation was, I look back a second, our equation was C equals L plus 6. I rearranged that a little bit, right? I'm going to get C minus L equals 6. Right? Well, in my solution, I wanted to do that, C minus L equals 6, so that I could eliminate a variable. So now if I add these equations, I end up with J plus C, right? J plus C. L is negative because L plus negative L, right? Or 1L plus negative 1L is going to give me 0. So I eliminated my L variable. And if I add right hand side of my equation, I get 180. So I have J plus C equals 180. Okay? All right, so there's my first piece. All right, so you might ask now, where am I getting 7J plus 7C equals 1,260? I'm going to multiply my previous step. That's right here. I'm going to multiply my previous step by 7. So I have 7J plus 7C equals 1,260. Well, let's look up here for a second. 8J equals 7C. So I'm just going to replace 7C with 8J. So I have 7J plus 8J equals 1,260. Now what can I do? So I can solve for J. 7J plus 8J, combine like terms to get 15J equals 1,260. Divide both sides by 15, and I get J equals 84. So now I know that 1F, if I interpret this portion of the solution, I know that Juanita leg pressed 84 pounds. Well, now I'm just going to keep substituting. Now I can say, I can take my 8J equals 7C, and I can substitute 8J, so 8 times 84 equals 7C. Okay, if I just go ahead and simplify that, I'm going to get C equals 96. I'm going to divide both sides by 7. So now I know that Chen, I interpret Chen leg press 96 pounds. And then finally at the end, probably our easiest one, I have, let's see, C minus L equals 6. So I have Chen minus Lu equals 6. So 96 minus L equals 6. Again, if I go through and solve that, I'm going to get L equals 90 pounds. So Juanita leg pressed 84, Chen 96, and Lu 90.